Everything we can see in our universe is made of matter. Stars, planets, galaxies, and humans all consist of particles we know. But scientists believe this is only 5% of everything in the universe that exists. The other 95% is invisible, and we have never detected it. But if we never detected this invisible stuff, how do we know it exists? In 1933, the Swiss astronomer Fritz Zwicky did research about the Coma cluster. Most of the galaxies in this cluster had an average speed as expected. However, a few galaxies he observed did not. This would indicate they were zipping around very fast inside. But this was strange, because the Coma cluster is a stable system, and those incredible fast galaxies would cause the cluster to fly apart. But it didn't. Zwicky said there had to be some sort of mass in the cluster to keep it all together, even if we couldn't see this mass. He estimated the cluster contained about 400 times more mass than was visually observable. Nowadays, we know that Fritz Zwicky's calculations were wrong by an order of magnitude. However, he was right about the invisible mass. This is now widely known as dark matter. 95% of the universe consists of dark matter and dark energy. However, after more than 100 years, we still haven't detected it once. This also means the black stuff in the thumbnail is not dark matter, because we can't see it. But you have to be a bit creative when you can't see something. Dark matter and dark energy is officially still a theory. Most scientists do, however, believe and accept this theory. One of the biggest mysteries that led to the dark matter solution has to do with rotation curves of a galaxy. Don't worry, it's very easy to understand. A spiral galaxy is a flat rotating disk containing stars, dust and gas. In the middle they have a tightly packed group of stars. The light emitted decreases when you go from the center to the outside of the galaxy. All this light represents mass because the light is emitted by stars, dust and gas inside the galaxy. So the light distribution corresponds to the mass distribution. We can see lots of mass in the center and less in the outskirts. From Kepler's third law, it is expected that the rotation velocity, because galaxies spin, will decrease with the distance from the center. This also applies to our own solar system, because the Sun in the middle has the most mass, and the average mass of our solar system decreases with distance to the Sun. Mercury, the planet closest to the Sun, makes a circle around the Sun in only 87 Earth days. The Earth itself takes 365 days, as we all know, and Neptune, the furthest planet from the Sun, takes about 60,000 days for a circle around it. As you can see, the time it takes greatly increases when you go away from the center where the most mass is. Because a spiral galaxy is built the same, only on a much bigger scale, it would be expected to behave the same. Mass right next to the center has a high rotational velocity compared to mass on the outskirts of the galaxy. But this is not the case. After many observations throughout the years, we don't see this happening. Instead, the velocity of the mass on the outside is around the same velocity as the mass next to the center. This graph explains it very well. Line A is what we expected to observe in these galaxies. The velocity decreases with distance from the center. However, we see something that looks like line B. The velocity stays almost the same. If Kepler's laws are correct, and they probably are, the only solution to this mystery is some sort of invisible mass on the outside of the galaxy. This invisible mass would make the galaxy mass distribution the same everywhere, and therefore the rotational velocity would be the same. Dark matter is the thing we have come up with to explain this. We don't know what it is made out of. It could be some new subatomic particle we haven't discovered yet, or other forms of existing particles. We just don't know. All in all, we don't know if dark matter or dark energy is real, but there certainly are observations we don't understand at the moment. If you enjoyed the video, please consider subscribing. As a small YouTuber, everything helps. Thanks.